Sensory hook. The label you've carried for decades. You wake up before the house is fully awake. The room is quiet, morning light barely reaching across the wall, and for a moment, you simply lie there, breathing, feeling your heartbeat settle. Then you get up. Maybe you walk toward the bathroom, glance at yourself in the mirror, and notice the ordinary signs of another year passing. Maybe you reach for water, take your medications, or begin the routines that have become almost automatic. Somewhere in that quiet moment, there is a number you may already know by heart. Your blood type. O positive, O negative. Just a couple of letters and a symbol that have probably appeared on medical records, laboratory reports, or emergency forms throughout your life. But those letters describe something far more specific than most people realize. They reflect a molecular pattern carried across the surface of your cells, created by instructions written into your DNA. And if your blood type is O, there is a particular molecular step your cells generally do not perform. That sounds like a deficiency. It isn't. Your cells are not broken. They are following a different biological pathway, one that has been operating quietly every second you have been alive. This is the part that is easy to miss. Right now, quietly, while you go about your morning, your blood cells are moving through an enormous network of vessels, carrying oxygen, interacting with proteins, and presenting molecular structures that help your immune system recognize what belongs to you. Your blood type is part of that microscopic conversation. Yet almost nobody ever explains what type O actually means at the cellular level, or what your cells never built in the first place. By the time you understand that difference, those two familiar letters may never look quite so simple again. Dot, curiosity gap, and question lock. But what, exactly, is different about your blood if you are type O? It does not mean your blood is weaker. It does not mean your body is missing some essential nutrient. And it does not mean you were born with a special menu that every type O person must follow. Those ideas are common. They are also simpler than the biology. The real distinction is hiding in a place you cannot see without a microscope, the outer surface of your cells. And this is where the story becomes surprisingly specific. Your type O blood carries a molecular structure called the H antigen. Think of it as a foundation, a small carbohydrate pattern that can be modified into something else. In people with type A blood, one enzyme adds a sugar to that foundation. In type B blood, a different enzyme adds another sugar. Those modifications create the molecular signatures recognized as A or B. But with typical type O blood, that final modification does not occur. The foundation remains. The H antigen is still there, sitting on the cell surface, but it is not converted into the A or B structure. And that is the detail most blood type conversations skip. You already carry the clue inside your own cells. Your biology has maintained this molecular pattern throughout life. But there is one question we have not answered yet. Why should you care whether a carbohydrate structure gets modified or remains unchanged? That question matters because these molecules are not decorative labels. They participate in how your body recognizes cells, interacts with antibodies, and regulates other biological processes. Before we follow that molecular pathway deeper into your bloodstream, though, we need to separate what ABO science actually shows from the amount of advice that has been built around blood types. Anti-influencer credibility firewall. But before we follow that molecular pathway deeper, there is something you need to know. Blood type has become one of those subjects where a small piece of legitimate biology gets wrapped in a large amount of advice. You have probably heard that type O people should eat more meat, avoid certain foods, or follow a diet designed specifically for their blood type. You may even have heard that type O people are naturally stronger, more energetic, or built for a particular lifestyle. Those claims sound scientific because they begin with something scientific, but they often take one real biological difference and stretch it far beyond what the evidence can support. The version promoted by influencers is simple. Your blood type tells you how you should eat and live. The molecular version is much more precise. Your ABO blood type comes from a gene on chromosome 9. That gene provides instructions for enzymes called glycosyl transferases, which are proteins that attach specific sugars to molecular structures on the surface of your cells. In the common type O pathway, a small deletion disrupts the enzyme's normal function. As a result, the A or B modification does not occur. That is fascinating biology. And frankly, it is far more interesting than blood type personality tests or rigid diet charts. I find that kind of wellness content frustrating because it takes something specific and turns it into a slogan. You deserve better, really. You deserve to know what the molecule is doing, what the research actually measured, and where the evidence stops. Because your blood type can have biological associations. It can influence which carbohydrate structures appear on cell surfaces, how antibodies recognize those structures, and differences in proteins involved in clotting. But none of that means your blood type dictates your entire lifestyle. There is a useful trail to follow. Gene to enzyme, enzyme to cell surface carbohydrate, carbohydrate to immune recognition, and eventually to coagulation biology. That pathway is where the story lives. And because this channel is interested in mechanisms rather than labels, let's establish why that distinction matters before we follow the chemistry dot. Soft CTA number 1. Why this channel explains the mechanism. That pathway is exactly why this channel takes a different approach. If you are approaching your 60s, 70s, or beyond, you have probably heard enough health advice that tells you what to do without explaining why. You deserve the second part. Understanding your physiology gives you something a trend cannot: context. It helps you recognize which claims are supported by biology, which are uncertain, and which sound impressive because nobody explains the details. If you value evidence-based explanations that respect your experience and never ask you to accept a health rule blindly, consider staying with this kind of content. That is what this channel is built around. Because useful health information is not always another list of foods or supplements. Sometimes it is understanding the machinery already operating quietly inside you. And now, we can return to the beginning of the pathway, before your blood cell ever displays an O dot. Mechanism chain. The molecular architecture of type O. Go back to that blood cell for a moment. Before it becomes type O, its identity begins much earlier, inside the DNA that provides instructions for building proteins. One of the key pieces is the ABO gene, located on the long arm of chromosome 9, at a region called 9q34. This gene contains 7 exons, sections of DNA, that contribute to the instructions used to build its protein product. In simple terms, your blood type begins as a genetic instruction, not as a mysterious property that appears after birth. That instruction matters because the ABO gene helps produce enzymes called glycosyl transferases. The name sounds complicated, but the job is simple. These enzymes attach particular sugar molecules to existing structures on the surface of cells. And here is where type O takes a different route. The common A and B versions of the ABO gene produce functional enzymes. Those enzymes can modify a structure that is already sitting on the cell surface. The common O version, however, contains a single guanine deletion at position 261. That change shifts the reading frame, producing a protein that lacks the enzymatic activity needed to create A or B antigens. One tiny change in DNA, a very different molecular result. But there is another structure you need to know about first, the H antigen. Think of the H antigen as the foundation on which the A and B structures are built. It is produced on red blood cells through the action of an enzyme encoded by FUT1, a gene located on chromosome 19. Without that H foundation, the usual A and B antigens cannot be constructed on red cells. So imagine the surface of your red blood cell as a molecular landscape. The H antigen is already there. In someone with A blood, an A transferase adds a particular sugar called N-acetylgalactosamine. In someone with B blood, a B transferase adds galactose instead. Type O takes neither of those final steps. The H antigen remains largely unmodified. That is what your cells never built. Not a missing blood cell, not a missing nutrient, not a defective body. A specific molecular modification simply does not occur. And that distinction matters because these structures are visible to your immune system. ABO antigens are carbohydrate structures displayed on red blood cells, and related ABO structures can also occur on other cells and tissues. Your immune system is constantly distinguishing what belongs to you from what does not. In type O plasma, naturally occurring anti-A and anti-B antibodies are present because A and B antigens are absent from your own red cells. This is why blood compatibility can become a matter of life and death during transfusion. Your immune system does not treat these molecular patterns as meaningless decoration. But the story does not end with red blood cells. Here is the part almost nobody talks about. The ABO system also intersects with proteins involved in blood clotting, particularly von Willebrand factor, or VWF. VWF is a large protein that helps platelets adhere at sites of blood vessel injury and also carries and stabilizes factor VIII, another important protein in coagulation. Researchers have consistently observed that healthy people with type O blood tend to have lower circulating levels of VWF and factor VIII than people with non-O blood types. A commonly reported difference is roughly 25%, although individual levels vary considerably. Why would a carbohydrate blood group system affect a clotting protein? Because the ABO structures can be attached to proteins circulating in your blood, their carbohydrate patterns can influence how those proteins behave and how quickly they are cleared from circulation. ABO type can influence laboratory reference ranges for VWF and factor VIII. One study of 217 healthy donors found VWF and factor VIII levels in the type O group were about 75% and 78%, respectively, of the corresponding levels observed in non-O groups. The same study found thrombin generation was approximately 10% lower in the type O group. Those numbers are population findings, not predictions about you. That distinction matters for your health decisions. Your blood type does not tell you that your blood will clot too slowly. It does not tell you that you are protected from a heart attack or stroke. And it certainly does not make type O automatically healthier. What it does reveal is something more interesting. Your blood has a slightly different biochemical environment. That difference can influence the balance between clot formation and bleeding. On one side, lower average VWF and factor VIII levels are associated with a lower tendency towards certain thrombotic events. On the other side, lower clotting factor levels can contribute to a greater bleeding tendency in some circumstances. The relationship is a trade-off, not a health score. A much larger study makes this distinction especially important. Researchers examined data from more than 1 million blood donors in Denmark and Sweden, representing approximately 13.6 million person-years of follow-up. They recorded 9,170 venous thromboembolic events and 24,653 arterial events. Compared with type O, non-O blood groups had higher rates of several thromboembolic conditions, including deep vein thrombosis and pulmonary embolism. That sounds dramatic until you remember what the study actually tells you. It describes an association across populations. It does not mean that being type O guarantees protection, or that being type A, B, or AB guarantees a clot. Age, smoking, obesity, cancer, immobility, blood pressure, diabetes, medications, inherited conditions, and many other factors matter enormously. Your ABO type is one piece of a much larger biological puzzle, and that is the remarkable part. A microscopic difference that begins with a genetic instruction can travel through an entire chain. DNA influences an enzyme. The enzyme changes a carbohydrate. That carbohydrate becomes part of the cell surface. The immune system recognizes those structures, and related carbohydrate patterns can influence proteins involved in coagulation. You began this section wondering what your cells never built. Now you can see the answer more clearly. They never completed the A or B modification of the H antigen. And yet nothing about that makes your cells incomplete. They simply followed another pathway, one that has been operating continuously, quietly, every moment of your life. The ordinary interpretation of type O begins to fall apart here, because what looks like something missing is actually part of a different molecular design, dot contrast frame, missing something or following a different path. You may have heard type O described as though something important is missing. That interpretation is understandable, especially when medical information is reduced to simple labels. After all, type O red cells do not display A or B antigens. But the biology tells a different story entirely. Remember the H antigen we just followed? It is still there. In typical type O blood, that underlying structure remains largely unmodified because the functional A or B transferase activity is absent. Your cells are not failing to complete a necessary job. They are following a different molecular pathway. That distinction matters. Imagine looking at two houses and noticing that one has a red door while the other does not. You would not automatically conclude that the second house was unfinished. You would first ask whether the door was ever part of its design. Your blood is similar in principle. Here, the version most people have heard is, type O means you are missing A and B. The biological version is more precise. Type O means the H precursor is not converted into the A or B structures. And there is another mistake worth correcting. You may hear that because type O tends to have lower average levels of von Willebrand factor and factor VIII, it gives you natural protection from dangerous clots. That conclusion goes too far. Those lower average levels can be associated with a lower risk of certain thrombotic events in populations, but they can also be associated with a greater tendency toward bleeding. More importantly, your blood type is only one variable among many. Your age, blood pressure, smoking history, body weight, cancer status, physical activity, medications, diabetes, previous clots, inherited conditions, and overall cardiovascular health can all influence your actual risk. So type O is not a protective shield. It is one biological characteristic, not a diagnosis, guarantee, or personal forecast. That may sound less dramatic, but it is much more useful. It keeps you from making two opposite mistakes, ignoring a genuine biological difference or turning that difference into a prediction about your future. Neither extreme is supported by the evidence. Once you stop treating your blood type as a health score, you can understand what it actually tells you, and just as importantly, what it does not. So if the biology is real, but the popular conclusions have become exaggerated, where exactly did that confusion begin? Belief reframe. Type O does not give you a special diet. You may have heard that type O blood means you should eat a particular kind of diet, often one centered on meat, protein, or foods described as more ancestral. The idea sounds reasonable at first, because your blood type really does reflect inherited biological differences. That is where the confusion begins. Your ABO type changes specific carbohydrate structures on your cells and influences certain proteins in your bloodstream. So it is easy to take the next step and assume that those differences must determine which foods your body needs. But that leap is much larger than the evidence allows. The version you have been told is simple. Your blood type tells you what foods are right for you. The research-supported version is more careful. ABO creates real biological differences, but those differences have not established that you need a specific blood type diet. A systematic review published in PLOS One examined the evidence behind ABO blood type diets and found no supporting evidence that following these diets provides health benefits because of your blood type. That does not mean your blood type is meaningless. It matters enormously for transfusion compatibility, and it is associated with measurable differences in proteins involved in coagulation. Those are genuine biological effects. What the evidence does not give you is a personalized menu based solely on whether your blood type is O. And you do not need to feel foolish if you once believed otherwise. The original idea sounds plausible because it starts with a real biological difference. The problem is what was added afterward. Your blood type is useful information, It is not a personalized diet prescription. That distinction can save you from unnecessary restrictions and let you focus on factors that have much stronger evidence behind them. Overall diet quality, adequate protein, fiber, physical activity, healthy body weight, blood pressure, blood sugar, sleep, and the medical conditions specific to you. Once you remove the diet mythology, something much more useful is left. Understanding what your type O status can actually contribute to your health decisions. Circular close. The two letters on the page. Think back to that quiet morning when you saw those familiar letters on your medical record, O positive or O negative. They no longer look quite so ordinary. Behind them is a genetic instruction, an enzyme pathway, the H antigen, and a molecular pattern your cells have carried throughout your life. That pattern also helps shape how your immune system recognizes cells and is associated with measurable differences in coagulation biology. Every heartbeat carries that biology forward. Every circulation cycle repeats it. And every morning, you wake up with the same molecular architecture quietly doing its work. The real lesson is not that type O makes you special, but that your body is far more specific than the label suggests. If this kind of explanation helps you understand your body rather than simply follow another health rule, consider staying with us. That is what this channel is built around, making the science behind healthy aging understandable and useful.